torque transmitted by disc or plate clutch. So figure shows friction disc. Figure shows friction disc or a single plate clutch. Let MT is the torque transmitted by friction in Newton mm. F FA is axial force. Mu is coefficient of friction. P intensity of normal pressure. R1 inner radius. R2 outer radius. D1 inner diameter. D2 outer diameter. DM RM mean radius. DM mean diameter. N is the power transmitted. Small n is speed in RPM. Small d diameter of shaft. N is the KVA factor. I number of active surfaces. I1 plus I2 equals -1. I1 number of driving discs. I by 2. I2 number of driving discs. I by 2 plus 1. Consider elemental ring of radius R and thickness as shown in figure. Area of elemental ring is 2 pi r dr. Axial force on elemental ring 2 pi r dr and P. Total axial force Fa is integration of R1 by R2 2 pi p r dr. Equation 1. Friction force on elemental ring is mu P 2 pi r dr. Friction moment force moment of frictional force about the axis of torsional torque elemental ring is 2 pi p 2 pi r dr into r. Total frictional torque per active surface MT equals to integration of R1 by R2 2 mu pi p r square dr. So there are two cases to obtain torque capacity: uniform pressure and uniform wear. Uniform pressure, according to this criteria, it is assumed that pressure is uniformly distributed over the entire surface of the frictional disc. This assumption is used for new clutches employing number of springs. Hence, since pressure is uniformly distributed, P is constant. Axial force of Fa is integration of R1 by 2 pi p r dr. 2 pi p is constant. Integration of r dr 2 pi p r square by 2 r1 to r2. So pi p r2 square minus r1 square. The axial force Fa is pi p d2 square minus d1 square by 1/4. Question 19.86. So frictional torque per active surface MT is r1 by 2 pi p r square dr. So 2 pi mu p integration of r1 by 2 r square dr. So 2 pi mu p r square cube minus r1 r2 cube minus r1 cube. Upon 3. So 2 pi mu Fa pi r2 square minus r1 square r2 cube minus r1 cube by 3. So because Fa is pi p r2 square minus r1 square. So equals to 2 by 3 mu Fa R2 square R2 cube minus that is 1 mu cube R2 square minus R1 square mu FA by 2 2 by 3 2 d cube minus d1 cube d2 square minus d1 square mu is 1 by 2 mu FA dm dm 2 by 3 d2 cube minus d1 cube and mu is 1 by 2 mu FA dm I uniform where theory. According to this criterion, it will assume that uniform where is uniformly distributed over the entire surface of the disk. The assumption is used for one outlet is rate of wear is proportional to PV where V is rubbing velocity since V is omega into R, for PR is constant. So axial force FA is R1 by R2 integration of 2 pi PR dr 2 pi C R1 by R2 dr. For F equals to 2 pi C R2 minus R1. So from equation 1, MT is integration of R1 R2 2 pi mu PR square dr 2 pi mu C R1 R2 R dr 2 pi mu C R2 square R square by R2 R1 R2 2 pi mu C R2 square minus R1 square. Pi mu Fa 2 pi R2 minus R1 R2 square minus R1 square equals to 1 by 2 mu Fa R2 minus R1 mu Fa Rm when T equals to 1 by 2 mu Fa dm and dm is mean diameter d2 minus d2 plus dm by 2 transfer the I friction force MT is 1 by 2 mu Fa dm I. Axial force Fa is 2 pi C R2 minus R1 2 pi PR R2 minus R1. Since maximum pressure occurs in the radius Fa 2 pi PR 1 R2 minus R1 1 by 2 P D1 D2 minus D1 9.83.